we will be discussing a method for determining the distance of nearby stars, and by nearby we mean stars which are a few light years away from the Earth, using what is called the parallax method or the parallax technique. What is this parallax? Parallax refers to a very interesting observation that we've all made at some or the other point of time in our lives, that when we have a nearby object and we change our position for observing this nearby object, then its background appears to change. You know, for a simple example, what you can try doing is keep a pen or a pencil, say about 1.5 feet from your eyes, and cover one of your eyes with your hand, and then shift the position of the hand to cover the other eye. And as you shift the position of your hand from one eye to the other and alternate this quickly, the pencil or the pen appears to start running left and right, because the position from which we are viewing this pen is changing a little bit from one eye to the other, and the background therefore appears to shift. So if we are looking at some object, say S1, from this position, say S0 from this position, in the background we see an object S1, and when we see the same object from this position, in the background we see another object S2, and this is parallax method. Now we've seen this at work when we travel in trains or on the highways. When we are traveling on a highway and we are looking at the trees nearby, then the trees nearby appear to move back very fast, whereas distant trees and distant objects kind of appear to move with us, and this is actually the result of the same parallax effect. Now using this parallax method or the parallax approach, we can determine distances of stars which are reasonably close to the Earth. Now we'll be using this approximation here, that when we draw a circular arc of radius r, and the arc is a small one, it subtends a small angle theta at the center, and the arc length of course is radius times the angle, and in such scenarios this arc length is almost equal to the length of the chord drawn from point A to point B. So the straight line here has the same length almost as this arc. This is an approximation, we've discussed about it earlier as well, and we'll be using this in determining the distances of these nearby stars. Now coming to this figure here, let's say there is the sun at the center and the Earth is revolving around it, and we all know that the orbit of the Earth around the sun is very nearly circular. It's elliptical, but it's very nearly circular, and we'll be making that assumption that it's circular. The distance of the Earth from the sun at any point of time is called the 1 astronomical unit, AU. 1 astronomical unit is AU, and that we're all aware the value. Now as the Earth is revolving around the sun, what we will be doing is we'll be observing a star S0 from two diametrically opposite positions of the Earth. So initially we observe it from point Q, and we look at star S0, and we find that in its background there is another very very distant star S2, and say after about 6 months, when we reach the diametrically opposite position, which should be 2 astronomical units away from Q, from P we observe the same star S0, and in the background now we can see star S1. Now we identify these two stars, and then we measure the angle between these two stars. Now obviously we can't actually come here and measure the angle physically, we arrive at an approximation here. What we do is, since this distance of the star from the Earth is very small in comparison to the distance of this star from the background stars, this distance is very, very large compared with this distance, and therefore we assume that the angle which the stars subtend at this point is almost the same as the angle which these two positions subtend on the Earth. So from the Earth we look at the two stars, and using a telescope we measure the angle between the stars and assume that this angle theta is almost the same as this angle theta, because this small change in position from here to here does not really alter the angle between the two stars a great deal. And so now coming back to our relation between arc length and radius, let's look at this triangle here, this one, PQ and S0. We are interested in calculating this L. Let's assume this to be the radius, this is the angle, and this chord length PQ, which we know is 2 astronomical units, should be L times theta. Since we are already aware of theta, L comes out to be 2 astronomical units divided by the angle theta. So this is our parallax method, which gives us the distance of the Earth from a nearby star. Of course, for this to be reasonably accurate, the star needs to be fairly close, and the stars in its background need to be very, very far, and then this method of estimating the distance works out fairly well. Thanks very much.